Hello everyone, today we're going to be looking at classes versus objects in Python object-oriented programming. And you can see what I've presented here thus far is just a couple of keywords on the main terminology which we will be using to discuss these concepts. The first obviously would be a class, which according to a very broad definition would be a blueprint or a template that does not allocate memory to the server and only serves as code by which to define objects. And then objects, so this is the main difference, but it wouldn't become clear until later on throughout this tutorial. So suppose that you had the intention of creating a couple of objects in your memory. So for example, person 1 name, person 2 surname, that should be person 1's name as well, and then person 2's name or surname, person 3's name or surname. And you would notice that this would actually really take a hell of a lot of coding before for each new person that you add to your list, you would have to define a new variable each time. So in this case, I wanted to add my own name to this list and my own surname to this list. Then I would have to actually go and copy and change each and every variable according to what I'm trying to define over here. So that would actually really not be the best approach to take care of this situation. But a better way would then obviously be define a class which then does not take up any memory in the computer hardware, but rather just serves as a piece of code, as a blueprint through which we can then instantiate new objects, and that object is then stored into memory instead. So in this case, I've defined using Python a class which I called parent, and by definition the first line, this is the constructor method inside of the class. So you would see also here under the keywords again that we have properties and methods. So these are just special names, but pretty much they mean variable or function in the context of classes. You're used to variables, and so over here we've used variables in line 2. And we would also need methods, which really comes down to functions inside of a class. So the first one here is the constructor method there. And basically what that refers to is just that it's the method which is automatically runs once the class is instantiated. And we haven't yet gotten to that point of instantiating the class. It would make more sense in the next line, I guess. But I just want to go through the definitions here. We have the constructor method, which takes as arguments self, the name. These are keywords as also described over here. You could use this instead. Well, they are used to refer to the current class within the scope of that class. So in other words, it's going to refer to the init method. We also get the definition getName method, right? And we have the getSurname method. And I will show you how to use that in just a second. So what that's going to do is it's going to take the name that you've given the class upon instantiation, and it's going to take the surname which you have given the class upon instantiation, and it's just going to rename it to name and surname. And then we can return these values by running them as methods. So I'm going to then just quickly run that. And now we've actually told Jupyter Notebook what the class is, all of its methods and everything inside. I just want to show you what will happen if we instantiate the class and how we would do that. We would have to go and make 3 new instances of that class. These become objects. Okay, this here is the instantiation of the class above of parent, in which I have to give it 2 parameters. There's no need in Python to give it the parameter self, because self would always be a parameter in any of these methods. So in the case of the constructor method, I've included the keyword self. In case of the getName method, I've included the keyword self, as well as in the getSurname method. And so now we have these new 3 objects, parent 1, parent 2, and parent 3. And if I now execute this line of code, it's just going to tell the server that I have these new three new objects, which are then stored into memory. And now we can go and actually go and get the names and surname by running them as methods on top of that class. So here you would see I take parent, that's the object the instantiation of a class, object 1. And then I call using pair get name in braces, because this is the method, it's got braces because it's coming from within the body of the class. And then the same for get surname, it's coming from this function or method over here. And so if I run this, I will get all 3 names and surnames for each parent. So yeah, that's pretty much how you would use a class in the most rudimentary way. But then of course, there is a lot more to discuss. We are ready to discuss inheritance of classes and access modifiers in a bit more detail. Best way in which to explain inheritance of classes, I'm just going to go ahead and create a new class, child, since this child class will now inherit information or methods and functions from the person class above, which we have already defined over here in line 3. Basically, I'm just going to pass through that class, meaning I'm not going to add something special there. I'm just going to basically inherit everything from person. In other words, these methods right now under class is now available to the child class. We've passed person as a parameter to that class. What we're going to do now is we're going to define 3 more objects. In our case, let's just say that you have 3 children, child 1, who is now going to be the child of Bob Dylan. In our case, that's going to be a child, but we don't have to refer to person no longer. We can now refer to child. All the properties and methods will then be available to that object as well from within its parent class, person. So in our case, let's say Madonna. I don't know actually who the real child is of Bob Dylan. Madonna, and then I don't know, makeup surname Madonna. So in our case, we're gonna have three children. I think Rob Zombie doesn't actually have a child, so I'm just gonna write Rob Zombie. I think his surname is Cummings, and then Joe Rogan has child Lola something, Lola Rogan probably, right? And now what we can do is we can run that, store its memory, and now if I want, I can actually refer to the get name method in the parent class as if I were to refer it to the child class. And I'm going to do that for all 3, get name as well as get surname, and then I'm going to print that to the screen. Just bear with me. If I run that, I should get all the children of previously defined parents. And so yeah, that basically explains to us how inheritance works in a rudimentary way. For the last bit, let's quickly look at access modifiers. All this really tells us is that certain properties and methods within this defined class would become accessible to other classes depending on whether they are defined to be publicly accessible, private, or protected. So by default, all these properties and methods that I've defined over here are available publicly because I have not restricted them in any sense. So to define them private method, so for example, if I go back to class person, and I would like to make this get name to be private, I would just put an underscore, a single underscore underneath before the method name. And if I now try and run that from the child class, in fact, even from within the class, since it's private, it cannot be accessed through that class. So that's because this is now protected and can only be accessed within the class. So if I wanted to, I can actually define a new function which is not protected, and let's call that get full name, which takes the same argument, but this time around it will return self.name. And if I change that to get full name, in our case, it's just still going to return the name because I didn't define it to add the surnames and stuff together. So get full name. This should be accessible to us. Okay, so if I run that, now I'm going to get Bob, Robin, Rob. Oh, that's because there's Rob Zombie and then Rob Zombie again. This is supposed to be, let's just say Bob Zombie. But it's still going to get Bob, Rob, Bob. So that's fine. Well, that explains most of what I wanted to say. I'll see you on the next one.